Hello, everyone. Welcome to the first edition of All Stack All Day. Thank you for having me here tonight. Today. And let's thank also to the organizers for putting this together, for this event together. Thank you so much. Okay, so a more appropriate title for my talk would have been "All frameworks are fast and slow." So I invite you today on a journey to look at performance from a different perspective. I'm going to make a bold statement today, telling you that a framework performance, as it is marketed to us, is not that important every time, and we're going to see why. Now, today we're going to look at one demo that is implemented in 3 different frameworks, like pretty completely different frameworks. We're going to take a look at the rendering performance and debate ways of improving those. Okay, but first of all, I would like to make to state 2 things what this talk is not about. So it's not about you not using frameworks at all. Please do use them because they are really powerful tools. And second, it's not about which framework is faster than the other. It's probably quite the opposite, actually. So before we begin, my name is Andrei Pfeiffer. I work as a co-designer for SmileCloud Biometrics, a local product company focused on cutting-edge dental solutions. And as Bogdan mentioned, I'm also co-organizer of tim.js for more than 11 years or something. The local JavaScript meetup here in Timisoara. And if you want to reach out, you can check out my website, andreipfeiffer.dev. It's also a blog. I write from time to time technical articles from the web ecosystem in general and JavaScript in particular. And you can also reach out to me. I have all the contact details there in case you want to reach out. Cool. So let's jump into our first demo. So here there is, let me zoom in a bit. This is an implementation of Game of Life. Anybody knows what Game of Life is? A few hands. My water, is it over there? I don't think it's this one. Oh, I have it here. Thank you. So Game of Life is a so-called no-player game, which evolves by itself from a given starting point. It consists of a grid of cells, a 2-dimensional grid, and each cell can be in one of 2 states. We have dead cells in white and black cells in live cells in black. And each cell can change its state based on the number of live neighbors around it, given like a few very simple rules. We won't go through them. There are some details, but you don't need to know the details. So I can advance the generation. So the Game of Life is that each cell can be born and then lives a couple of generations, and then eventually some of them die. And this is a cycle, right? And from this, I have one preset here. So this preset I can advance manually, or I can hit play in this demo, and it would advance automatically. And I have different presets. So this is a shape that changes every 3 generations, and so-called oscillator. Here I have a spaceship shape that travels horizontally. Now this re-renders 2 times a second, so once every half a second. I can make it go faster, 10 times a second. And I can make it even faster, like using request animation frame. And the browser will try to re-render as fast as it can, and up to 60 frames per second if the CPU and the graphics card can handle this computation. And you can see it's really, really fast. Great, everything looking good. But we have a relatively small grid here. A grid of 20 by 11, so roughly 200 cells are displayed and re-render each at 60 frames per second, roughly. If we move to a larger grid, you can see that now it is a bit slowed down. It's not moving that fast. Well, some things to note here. For this first demo, I'm using, it is implemented in React. And it's an unoptimized version of code. and React by default is not really that performant. It is simple compared to others, but yeah, it's not that efficient, let's say. I'm also using a development build, not a production build. This would be much faster on a production build. And also my laptop is not the latest generation hardware, so it's not great, but definitely not terrible. So let's see what is going on here. I'm going to open my Chrome DevTools, and I'm going to the Performance tab and hit the record button. We're going to let it record for a few seconds, and then hit stop and let the browser load the profile to see what's going on during rendering. I'm going to stop here. Okay, so let's look at this flame chart. So you probably see some blocks here, some red blocks called tasks. And each of these tasks basically represent one re-render of the UI. So computing the new state and then rendering on the screen. And you can see it takes 400 and something milliseconds to re-render everything, like almost twice a second, which is really, really shitty, really slow. In order to execute this at 60 frames per second, which is a standard, this task would have to execute within 16 milliseconds. 16 milliseconds, 1 second, which is 1,000 milliseconds divided by 60, you get 16 milliseconds. And you can see in the browser here, these are called frames, and these are yellow. And it reads that it's a partially presented frame, so the browser cannot draw something on the screen because the call stack is occupied executing JavaScript code. And you see a lot of yellow here on top and here on the bottom as well. When you see yellow, it means there is a lot of scripting going on, which means executing JavaScript code. So it cannot draw anything on the screen. So there are two things that are happening each generation, so inside each of these tasks. First, we have to compute the new state of the game, like take the current state of the grid, iterate through each cell, look at the neighbors, and compute the new state of the cell based on the rules that I mentioned in the beginning. And we have to do this every time for each cell, each time we want to re-render. This is our own code. This is the business logic of the application, right? And then after we get the new state, after we have computed it, we have to pass it to our rendering engine or whatever we are using to render this on the screen, in this case React, and React will basically update the DOM elements in order for us to see the changes on the screen. Now at this moment we don't know exactly where the bottleneck is. We don't know if it's in our own code or the framework code. But that's something that's easy to determine. So I have used the Performance API. It is a web standard API that you can use. And you can basically measure how long it takes a function to execute. And the nice thing about that API is that you can also see the results here in Chrome DevTools. And if we zoom in at the beginning of the task, if we zoom in here and look at the timings lane, we can see that something appears here which reads get next population. This is the name of my function that basically calculates and computes the next state. And you can see it executes like really fast, less than 1 millisecond. So compared to the 400 milliseconds of the entire task, we can tell for sure that it's not our code that's slow, it's the framework code that is slow. So as I mentioned, this is unoptimized code. So let's try to optimize it to see if we can make it any faster. I'm using React 19 for this example, and React 19 comes with a built-in compiler, React compiler, that is supposedly able to optimize our code magically. I don't know what it does, but let's see if it works. So I'm going to open my vite-config, and I just have a flag here that I can flip to true to enable automatic optimization for the entire application. It's just a flag that you need to pass. It does this out of the box. And now if we hit play here, you can probably see that it's moving much faster, but we should do the profiling to be sure that it's definitely executing faster. And zooming in here, we can see the same tasks, but they take less time, like 4 or something times faster, right? Okay, this is good. But I also wanted to try a manual optimization as well, which, if you are a React developer, it's really trivial to do. So I'm going to open this component here, live component. This is one component that renders the entire grid. So it's a function that iterates through some rows and then iterates through some cells. So it's a nested, 2 nested for loops. Now, in React, one particular thing about React, or this example actually, is that not the entire grid actually updates each time, right? Only a few of those cells. Most of them, as you can see, are white, right? They don't change from generation to generation. So we can tell React, hey, if the input for a particular component doesn't change from one render to another, then don't render it at all, which will improve the speed of the rendering. This is called memoization in React. It's very simple. You just use React memo and wrap an existing component, an unoptimized component. You wrap it in React memo and use the optimized versions of the component instead. Optimized row and optimized cell. This is something very trivial to do as a React developer. And now if we hit play, I don't know if it's visible on the screen, but we will prove it by profiling this example, that everything is much, much smoother, like 10 milliseconds, 20, okay. So this runs at roughly 30 frames per second, which is pretty good compared to our previous examples or previous iterations. So I know this is a very simple and somewhat contrived example, but applying the automatic optimization for this example, I would assume that the result would be similar to what an experienced developer could do. But I would assume that using the React compiler on any project is going to be definitely much faster than not without any optimization at all. But I'm also convinced that experienced developers can do better than these magical stuff that the React compiler would do. I believe that. Okay, so this executes really fast, or good enough, or fast enough, but only in this particular scenario. Like, I have one last preset that I want to show you, which renders a larger grid of elements. And now if we hit play, I made it slow again. And this is basically a reality of performance, because performance usually degrades over time. Because requirements change, because data gets increases as time, also code increases, and everything increases, everything changes over time. So performance is not something that once you made the necessary efforts, it's going to stay like that forever. No. And also, it's not that the entire application or your entire project is slow. Usually, these bottlenecks surface are very isolated, somewhere in particular parts of your applications, and sometimes even in particular states or for particular users. So it's not something that it's easy to detect. Okay. And also, you might think that this is a contrived example which doesn't apply to your everyday code, because this is like a game. And I also have given it a lot of criticism, like whether I should talk about this here today or not. And the conclusion that I came up with is that, well, this is a real example. Like, it's not a made-up example of a made-up benchmark in order to prove that one framework is faster than the other. I mean, I actually built this because I wanted to build this, and then I encountered these bottlenecks and had to deal with them. And also, like, let's be honest, real performance issues, they don't surface at small scale when, I don't know, clicking in an interface or doing CRUD interfaces or having a few data available. They usually surface when we are dealing with large amounts of data, when we are executing really costly algorithms, or when executing code very frequently, for instance, during scrolling or while dragging something on the screen or when typing a bunch of stuff on the keyboard very fast. That's when these problems occur. Okay, so I should mention that I have a relevant experience with React. I think I understand pretty much how it works internally, and I'm sure that I cannot do anything more in order to improve the performance, because there isn't anything to do from my point of view. Because React is, I would say that it's dumb in regard to rendering. It doesn't know whenever we update when we do a change, state change, it doesn't know which elements in the DOM to update. It doesn't know that. It has to figure out what DOM elements to update in the DOM. So there is this process called diffing, reconciliation, taking one virtual DOM to compare to other virtual DOM, and it's a very, very costly process. And this, the limiting factor in this process is the size of the tree that has to be updated. So in order to avoid large trees, like here I have many, many, many elements that have to be re-rendered or to be computed in some way at each new computation of state. And I wanted to try one last optimization on this demo. So instead of rendering on HTML, on DOM, I rendered everything on a canvas. So now I don't have a bunch of HTML elements. I have only one single element, a canvas. And when I hit play, you can probably tell that this is like lightning fast. Going to profile this just to make sure that it's visible in the back. So now each render or each computation is executed during this 16 millisecond time frame, and everything runs at 60 frames per second. There is also a lot of idle time, like all this here, all this time that you can see in gray is idle. So how do you make React fast? Avoid using React. Yeah, avoid using it, because currently, at this point, I'm using React only to manage the state of this UI, so to manage the stuff, but all the rendering is not happening in React. Like React doesn't do any effort, any diffing, nothing. I'm just using imperative APIs to update the canvas, to draw on the canvas each frame. Okay, so from the beginning, I kind of had the idea that React is not suited for this type of application. But because of this dumbness of React that doesn't know what to re-render, and reactive frameworks, on the other hand, are more suited, or in my vision, are more suited for this type of things, because a reactive framework, when you have a state and you use that state in some part of your application, the components, they track this dependency between the state and where the state is used. So whenever we trigger some change in the state, reactive frameworks based on this dependency tracking, they know surgically and exactly what needs to update, what DOM elements to update. So they don't have to figure out, which makes them more effective, more magical, more smart, but more effective at the same time. So I tried to write the same, or to implement the same example in Vue. Vue is a reactive framework, and my first iterations, I mean, the first examples are really fast. Okay, no surprise here. Like if you're doing low amount of work, everything will be fast. If we're moving to the last example, this is what I get. A reactive framework, it's not that fast. Let's see what is going on when we profile this. Let's hit stop. Ooh, I don't know what is this. Okay. So I have the same tasks, 300 milliseconds, really slow. But funny enough, my function now is really slow as well. it takes 200 and something milliseconds to execute the computation of new state, which is really, it surprised me, okay? Now, the thing that with React, you usually work with plain JavaScript objects, with POJOs. In a reactive framework, you work with reactive data structures. So basically objects that are imbued with a bunch of proxies in order to track the dependencies between the state and the components where you use those. The framework needs to intercept to monitor whatever is changing or reading through each of these objects. So the objects are more complex. The state is more complex in reactive frameworks. So if you don't know Vue, it doesn't matter. I'm just giving some very brief details. So I'm using a ref here to wrap my entire state. A ref takes an inner value and returns a reactive and mutable ref object. So basically, what doesn't matter how deep or how large the object is, it will make it deeply reactive, which apparently is very, very slow. But in Vue, there's also a shallow ref, which a shallow ref is a shallow version of ref. In the documentation, it is stated that in case refs or whatever reactive data structures are slow, just use a shallow ref. Okay. Let's refresh that, hit play, and now we made this a bit faster again. So my function now takes less time, 13 milliseconds, everything runs a bit more smoothly. Not as probably, I don't know, compared to React or whatever, but the impression that you get visually is that they are pretty much the same. So how, in case of reactive frameworks, they are, as far as from my past experience, they are really great when you have really fine-grained updates that you need to make in the UI, but not very many. Like here I have many updates, like there are a bunch of many cells that change during one render. So in this particular example, reactive frameworks seems to be less efficient when you have many updates to perform during a state change. Now, I'm not an expert in Vue at all. I'm sure that somebody with a better experience and will be able to improve this even further, but this is the best I could do. Now, one last thing about Vue. Vue runs a so-called eager evaluation reactive, or contains an eager evaluation reactive system, which, as far as I read, performs better for deep data structures. It is not that efficient on wide data structures. Now here we have our data structure is a two-dimensional array, so the depth is only 2 levels deep, but it contains many elements, so it is more wide than it is deep. And lazy evaluation reactive systems are more efficient with wide data structures. Now, solid.js is also a different reactive framework and performant as they market it, which includes a lazy evaluation algorithm. So it should be faster for this use case. Now, I should note that I've done multiple iterations and improvements over using Solid. In the beginning, it was like not impressive at all. But after a few iterations, this is much more performant than our previous examples. Here you can see the tasks, so 30-something milliseconds. It's pretty good. And I'm using reactive data structure here. So basically underneath, everything is rendering using a reactive data structure. It is fast enough. Thank you, Victor. I don't know if Victor is here. Victor Ionescu? No. He's also HTMX guy, but he's also the Solid guy. However, when I'm rendering to canvas, so on the canvas, I don't know if you can tell, but the difference in performance is almost inexistent. So I don't know why rendering on canvas, at least in my implementation, doesn't have the speed of the other frameworks. I have no idea. I've tried debugging this together with Victor, together with Attila Fasina. Attila Fasina was a speaker last year at revo.js. He's also a developer advocate for solid.js, and we couldn't figure out like what is going on here. Probably it's like an anomaly, but it just highlights like another thing about powerful tools. Like it doesn't matter if you're using powerful tools if you don't know how to handle them. Like, I don't know, me having a Formula One race car, but I'm a bad driver, so I don't know how to use that. Now, I don't want you to walk away with the fact that Solid is slow or is fast, or React is slow or is fast, because I mean, you can take away whatever you want from here, but I showed you that all frameworks are slow and fast, depending on how you use them for. So unless you are building really specific applications and you know exactly what tools you need to build those, then choosing a framework mainly on performance benchmarks or performance marketing and you know, the shiny graphs where my framework is faster than the others or handles more effort or more processing power, that's not as relevant as you might imagine. Why? Because we humans in general and developers in particular are really bad at predicting the future. We don't know what requirements or what bottlenecks will hit 1 year from now or 5 years from now, right? Any framework can be optimized up to a certain point, and all frameworks will be slow at some point. It's really, I mean, what we have to do is to learn to identify the bottlenecks in case we encounter any performance issues. Like the bottleneck could be in our own code, in which case the framework doesn't help you that much. We need to go back to computer science basics and data structures and algorithms to optimize those, that code. Or if the bottleneck is in the framework, like we have to learn the framework if we can use any of the built-in optimization methods they provide. They all provide one way or another. Or just avoid the bottleneck altogether, like we did rendering on canvas in the case of React, because React was slow, or using opting out of reactivity, because working with large reactive data structures could be slow. So whether your framework is slow and fast really depends on what you are, how much work do you require it to do. Okay, all the code is available on GitHub. You can check it out. There is also an implementation in Svelte. It's more or less the same. Sorry? Same. All are fast and slow, you know. Yes, and if you have any improvement suggestions, please feel free to open up a pull request or just drop me a line. I will be more than happy to talk to you in this regard. Thank you so much for being here. I know I went a bit fast because of the short time, but please, I will be in the break. I will be at the booth, just waiting to talk to you. Enjoy the rest of the event. Thank you so much. See ya.
Woo! Awesome.